Number 46. Write a balanced equation for each of the following nuclear reactions, and then we have letter A. So in this case, we have mercury-180 that's decaying into platinum-176. Okie dokie. All right, so if we're dealing with nuclear reactions, right, we have to do with nuclide notations or deal with nuclide notations. We always have to write the balanced equation with those three different things, right? I like to color them in different blocks, which look like this, right? So in this case, let's get started. Now, they said that we had mercury-180 and it's decaying, right? It decays into platinum. So I know that mercury, since this is the one that's decaying, this has to be the reactant. And what you're turning into, the platinum, that's got to be the product. So reactants are left side, products are right side. So we know that mercury is going to be on the left side, and then we yield the platinum, which is on the right. So let's start it. Mercury is Hg. So that's where the big blue box goes. It's your notation for whoever it is, right? And in this case, it's Mr. Mercury. Mercury. And they told us specifically it's mercury-180, which means that the numbers that they give you is always your atomic mass or your mass number. Now, the mass number can change for individual elements because you could change the number of neutrons, right? So the top number is the mass number. So they told us that we have a 180 on the top. But now what's the number that goes on the bottom? Well, that number is the atomic number, right? That number does not change for the elements, right? Each element has its own unique atomic number. They didn't tell us what it was. They just said mercury-180. So I have to go on the periodic table, get your periodic tables out, to find out what mercury's number is. And it's always going to be the whole number, right? Not the decimal number, because that's the average atomic mass. And for mercury, it is number 80. So 180 on the top, 80 on the bottom. And now we have mercury-80. Or 180, right? This is going to decay into platinum-176. So let's bring out another nuclide notation. Platinum, we'll put that, this is platinum. Platinum-176. They told us what the mass number was, right? 176. So I'm just going to put that on the top here, 176. Platinum is PT. So capital P, lowercase t for platinum. And now we have to find out its atomic number. So I go on the periodic table and I see that platinum has a 78 all the time. Okay, now if you just box this answer off and call it a day, almost there. Because remember, there's got to be something that's balancing the reaction out, right? Which means that your mass numbers, right, on the top, have to equal on both sides. But I have a 180 on the top for the mercury side and a 176 for the platinum. That's not balanced. The same thing for the atomic numbers, 80 on the reactant side, 78 on the product side. Which means that I probably have to add a subatomic particle. And we're talking about nuclear reactions, so we know that we're dealing with those particles, protons, neutrons, electrons, right, alpha particles, positrons. So let's find out what that missing piece to the puzzle is. So treat your yield sign as an equal sign, right? 180 equals 176, and I'm only taking the top numbers because that's the ones that you have to balance, and then you do the same thing for the bottom numbers. So 180 equals 176 plus what? How many numbers? Well, from 176, I need to plus 4, right? 176 plus 4 will get me a total of 180. So that's the number that goes on the top. And then we kind of do the same thing on the bottom. 80 equals 78 plus what? Well, 78 plus 2, right? So I'll put a 2 over here. And now, a 4 and a 2. I have an atomic number of 2. And I have a mass number, which means that this has to be some type of element, right? So I go on my periodic table and I say, whose atomic number is 2? And yeah, the only one that has an atomic number of 2 is helium. Now just know that a 4 on the top and a 2 on the bottom, a helium is the same thing as an alpha particle. So I would put alpha. But if you want to put the helium, you would be correct as well. This, a 4 on the top and a 2 on the bottom, is always your alpha particle, which is just a fancy way for saying it's a helium. Helium-4 specifically, not helium-3, not helium-2, or 5 or whatever. It's always a helium-4, 4 on the top and 2 on the bottom. And now my equation is balanced. So there you go. So when mercury decays into platinum, it just releases an alpha particle. So this would be beta emission, or not beta, alpha emission. Okay, what'd you think? I hope this helped. Let me know in the comments. Thank you so much for viewing the video. Subscribe to the channel, like the video. Just gets the word out there in the YouTube universe that this channel exists. We're almost at 50,000 subscribers at the present moment. And that's all because of you guys. So thank you so much. Check the channel out. We got memberships on the channel if you want to help us out a little bit more. You always can. Thank you so much for considering. And I'll talk to you soon, okay? Have a great day. Bye-bye.